Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing on the sequence stratigraphy of carbonate depositional environment. And in the last couple of classes, we have discussed about the overall conditions of carbonate depositional environments in terms of the carbonate factories, in terms of the different types of platforms where carbonates are deposited, and also we tried to get introduced with a new concept which is commonly applied to carbonate sequence stratigraphy only, that is the concept of drowning unconformity. So, with that background, today in this particular class we will try to understand about the different system tracts in carbonate depositional environments, and we will try to understand what are the overall or major attributes in terms of distribution of different depositional conditions, in terms of distribution of different depositional systems within one particular systems tract in the carbonate depositional environment, that we will try to understand. However, since we do not have much scope of going into the detail due to lack of time as well as looking into the overall purview of this course, so we will not go into the detail of the carbonate sequence stratigraphy, or will not go into the detail of individual systems tract, but within our limited scope we will try to give you a broad overview about the major attributes of the common systems tracts where we get carbonate deposition going on in different parts of a carbonate depositional basin. So, we can start with the high stand systems tracts, because this is the one systems tract where we commonly get the maximum amount of carbonate deposition. This is the most safest time zone, or in terms of the base level change, this is the safest period when we get the best carbonate deposition, the maximum amount of carbonate deposition. So, we will start with the high stand systems tract. So, the different stages of the high stand regression, we know during high stand it is a normal regression because of more sedimentation. So, these are most favorable in the development of the carbonate systems. We get this feature on the continental shelf area, as well as we get this within the deep water part into the deep water basin, and this is broadly because of two major reasons. Number one, the large scale flooding of the platform, which is characteristic of high stand, because we know during high stand the water level is very high, it is at its maximum or it is near to its maximum. So, during this high stand stage, the entire floor, entire platform is covered with water, and this is just after the transgression. So, that actually creates, or that actually provides a very large area in terms of surface area for carbonate production and carbonate deposition. So, that is one reason during HST we get maximum carbonate production. And secondly, during this high stand condition, base level is rising, and during this rise it is generating significant amount of accommodation where the platform is gradually growing. In carbonate system, platform gradually grows up by accumulation of the carbonate sediments. But the rise of the base level, its rate of rise is relatively low with respect to rate of sedimentation, and in this case it is the growth of the platform. So, the carbonate platform, it commonly maintains a balance in between the rise of the base level and the growth of the carbonate platform. So, in carbonate sequence stratigraphy, we commonly use the term that the carbonate platform is maintaining the balance, it is the keeping up, or it is the keep up phase with the rate of creation of the accumulation. So, as the base level is rising, along with that the growth of the carbonate platform is going on because of significant amount of deposition of carbonate sediments. So, when this keep up phase goes on, that is, that equilibrium is maintained, that balance is maintained, this ensures that there is no drowning effect, there is no carbonate factory shutdown, and as the rate of base level rise gradually decreases with time as we go towards the late phase of the HST, towards the end phase of the HST, we know that the rate of rise of the base level will gradually decrease. So, this decrease in base level rise with time during the high stand leads to the volume of carbonate sediment accumulation more with respect to the amount of accommodation creation. So, that volume of carbonate sediment exceeds the amount of the available accommodation, and because of that, since that cannot be accommodated within the self-hull area, so that is supplied to the deep water environment. So, during this HST phase, this particular phenomena, this particular process produces significant accumulation of clastic carbonates, reworked carbonates on the slope and on the basin floor. We commonly call this one as high stand shedding. So, this high stand shedding is a characteristic feature of HST in carbonate depositional conditions. During these high stand conditions, the production outpaces the accumulation, particularly if we talk about the platform top. And this excess of carbonate sediment, it is commonly transferred to the deeper water environment or the deeper water part of the basin, and that transfer, that reworking is commonly triggered by subsequent storm surges, frequent storm surges and associated gravity flows which are generating at the self edge, they are generating at the slope area, and they are carrying and transferring the sediments into the deep basinal part where the carbonates are getting accumulated. But remember, this accumulation should be above the CCD, the carbonate compensation depth, because below that depth the carbonates will go into solution. So, there we cannot get any further carbonate deposition. So, always this process, this high stand shedding is concentrated above the CCD in the deep basinal part. So, during this high stand regime, the amount of accommodation which is created on the platform top by this base level rise is commonly consumed entirely by the sedimentation, because that is maintaining that balance. So, whatever accommodation is created, it is immediately consumed by the sediments. So, effectively there is the accommodation available is 0, the net accommodation is 0, even though the water depth is rising, it is positive, and the base level and the sea floor in this kind of conditions are superimposed. So, when you have the net accommodation 0, that means the overall growth will go on in continuation with the rise of the base level, rise of the sea level. So, if I want to understand what happens during the high stand carbonate platform in terms of the distribution of different environments, different conditions. So, we are looking into the base level curve. So, maybe this is the curve part, maybe something like this. So, we are looking at this part of the curve. As we know, the high stand part is covering up this part of the curve. So, there may be successive such high stand conditions. Say for example, here we have a transgression, and after this we may have another transgression, and in between that we can have another high stand condition. So, there can be successive high stand conditions in the carbonate basins. So, during this high stand condition, if we look into the entire carbonate platform, so maybe it is like something like this. This is the self edge, self slope break. So, at this point, this entire platformal area, it gets significant amount of sediments, it is flooded, completely waterlogged, and that is why this entire area maintaining a very shallow water condition, remaining within the photic zone, and as a result we get significant amount of carbonate deposition in this entire area under relatively low energy condition. So, what kind of condition we expect? Towards the landward direction, in this part commonly we get a peritidal condition. So, this peritidal area very close to the continental side, having a very shallow water condition where it is within the photic zone. So, along with peritidal we can also get deposition of some evaporites, particularly if it is a high temperature zone. Then we get a lagunal condition or maybe a subtidal condition, or this entire area can be a part of a lagoon which is tidally affected, and we can get a subtidal and intertidal or peritidal condition. Then as we come into the outer side, there we commonly get a shoal area, or in certain condition we can get a reef is developing. Now this development of reef is also a part of that maintaining that balance which can form over here in this part, in this area. And when the reef develops, it becomes a rimmed shelf, because this backward area, this area which is lying behind the reef, that becomes more obstructed, more kind of barrier condition, and that becomes a low energy condition. Now from this area also we get a very thick deposition into the deep basinal part in the form of this high stand shedding, and that we get in the area of slope to deep basinal area. This is the part of the high stand shedding, where the sediments from this area, they are reworked from this zone and they are carried down by successive storm surges or successive gravity flows. So during the high stand condition, we get commonly the distribution of carbonate accumulation going on in these different zones, in these different parts. So when we are talking about this condition, what was the sea level? Definitely it is somewhere here. The sea level is somewhere where, or maybe even more than this. Sea level is somewhere here, and this particular depth is maintained, which is remaining within the photic zone, and that is helping in continuous accumulation of carbonate. So the carbonate shelves, they can sustain the formation of high stand system strats during the different stages of their evolution. As I told you, in this particular base level curve, so we can get high stand system struct developed over here, we can get a high stand system struct developed over here, and maybe high stand system struct after this phase of transgression, where we are getting a very sharp, very steep rise in the base level, followed by that we can get another high stand system struct. So there can be multiple such high stand system struct associated with transgressive system struct, and they can occur in cyclic pattern, stacked one after another. If we want to classify them, if we want to distinguish them, they can appear in different groups or different types. So broadly we can identify three types of HST, three types of high stand system structs for carbonate shelves. So they are commonly identified in terms of the overlying and underlying packages and the nature of the distribution of the sediments which are available in that particular HST. The first one is commonly called as an initial high stand system struct. Now this initial, this means the early development of the carbonate platforms. So at that time the base level is rising up and the carbonate platform is growing, carbonate platform is developing. We can also get an internal high stand system struct, where we get stacked HST overlying the transgressive part, overlying the TST. So in such cases, commonly the TSTs, they are relatively slow in terms of their rising base level condition, and that is why during the TST we get deposition of sediments, carbonates, and that is followed by an HST phase, which is also further associating or helping in the accumulation of sediments. So during this entire phase, the carbonate platform survives, it remains within the photic zone, and we get stacked accumulation of sediments within the HST. And the third one is commonly called as a final HST, which follows the drowning of the carbonate platform, which is commonly associated with rapid transgression, rapid rise of the base level, and which is overpacing the rate of carbonate accumulation, which is significantly increasing the depth and leading the carbonate platform to go beyond the photic zone, leading to shutdown of the carbonate factory. So in such cases, when we get such shutdown, commonly we get a drowning unconformity, as we have discussed in the previous class, and followed by that during the HST, after this transgression we get the HST, and during that HST we commonly get start of the deposition of the siliciclastic sediments on the carbonate sediments. So, that can be considered as kind of return back to the clastic systems on the continental shelf. So, the carbonate system is changing over into a clastic system, where just like a simple continental shelf, as we have discussed earlier, we can get similar kind of depositional pattern as we have discussed in case of HST in the clastic system. So, the initial and the internal HSTs, they commonly displays characteristic features of the carbonate shelves in terms of deposition of successive carbonate units, whereas the final phase that commonly marks the return to the clastic systems on the continental shelf and accumulates commonly on the top of the drowning unconformity. So, all these include the development of carbonate facies with respect to the base level on the platform top, which commonly maintains a very shallow water condition, very shallow water level, and the accumulation of the thick deposits of the clastic limestones to the deep water environment that commonly leads to the high stand shedding, and that can produce a thick deposit in the deep basinal part. During such stages, the carbonate platforms keep up, that is the term we use, keep up with the rise of the base level. That means they maintain a balance between the accommodation and the carbonate productivity, and the surplus carbonate sediments which are produced because of more sediment production leads to the progradation of the shelf edge, which is characteristic of HST. In contrast to that, when you look into the final high stand systems tract, this commonly consists of the high stand prism, like we have seen in case of a clastic HST in a clastic shelf and the marginal marine part, the simple high stand prism on the continental shelf and an associated condensed section of pelagic sediments, which can form commonly in the deeper portion of the basin starting from the shelf area, as overall the supply of the coarser clastics are restricted towards the marginal marine part of the basin. So, this already we have seen during our class on high stand systems tract, and in the carbonate system after the drowning unconformity, when we look into the final high stand systems tract, we can again go back, we can again get back to that particular system where we get siliciclastic high stand prism. This drastic change in the sediment budget across the continental margin commonly reflects the difference in the pattern of sediment dispersal between the clastic and the carbonate depositional environments. During the carbonate depositional environments, across the entire shelf, we are getting thick carbonate deposit, the keep up phase. Whereas, if we look into the clastic part, there we get a very thin deposit commonly represented by the condensed sections because of lack of supply of sediments into the deeper part of the basin or into the shelf area. So, there is a very drastic major difference in terms of the characteristic properties of the HST of clastic system and carbonate system. Now, if we look into the next phase in terms of the systems tract, so next one is the definitely the falling stage, and we can also consider the low stand systems tract along with the falling stage. So, we can combine them together, the falling stage and the low stand systems tract. So, following the stages of high stand normal regression, when the most accommodation which has been created across the carbonate platform is consumed by high rate of sediment production, high rate of carbonate production, and as a result of that, the depth of water across the entire platform is very shallow. So, if there is a minor fluctuation in the base level, even if it is of very small in magnitude, that will lead to rapid base level fall, and that will lead to forced regression immediately in the carbonate depositional environment. So, when it is a forced regression, what we expect, the base level is going down, and that will lead to subaerial exposure of the entire platform top. So, as soon as this kind of minor fluctuation starts in the carbonate depositional environment and the base level starts falling, immediately we get the entire platform or a major part of the platform is subaerially exposed. Such subaerial exposure of the platform top continues during the entire phase of falling stage, entire phase of forced regression, and it can even continue during the subsequent low stand normal regression, because even during this phase, as the base level starts rising, maybe during the forced regression it has gone down beyond the self edge and now it is trying to come up. So, during this phase even the platform which was subaerially exposed is not covered under water, and that is why we can consider these two conditions, these two phases, falling stage and the low stand interval, together as one stage, because during this entire stage the entire platform area or the major part of the platform area is subaerially exposed. So, the overall carbonate shelf, the overall carbonate platform, they have a completely different consequence, different scenario during this falling stage and the low stand condition. So, what happens during the FSST and LST during the carbonate platform? In this curve, we are now looking into this part. As we know, this is the forced regressive part, and followed by that we are looking into this part, the LST part. So, during the HST phase, what we have seen, this was the surface available, and on that surface we had this kind of the setting, the high stand setting. So, maybe this is the condition, this was the HST deposit, and this is the top surface at the end of the HST. This is the final surface available. Now, at that time the water level was somewhere here, the sea level was somewhere here, maintaining a balance. Now, from this level, base level starts falling. So, it is coming down to this zone. So, now the water is confined over here in this part, and that confinement of the water of the sea level is leading to the subaerial exposure of this entire zone. And when this area is subaerially exposed, the first thing that occurs is the shutdown of the carbonate factory. Since there is no water, there is no photic zone, no organisms, so definitely the carbonate production is stopped. So, there is the shutdown of the carbonate factory. And not only that, since this is now subaerially exposed, it will go through some weathering process, and there we can get some karst topography, karst features they can form over here in this part, which is nothing but like the erosions going on that we have seen in case of clastic systems, where the fluvial incision takes place, forming a subaerial unconformity. Exactly over here weathering process starts and we get an unconformity surface, which can be correlated or maybe considered as equivalent to the subaerial unconformity. So, we get this kind of karst surface or karst topography formed across the entire platform area. When the base level further goes down, maybe coming down to somewhere here, in that condition maybe some reworking going on over here, and that can lead to deposition of very thin deposits over here in this portion, very thin deposits which are commonly formed during this falling stage. So, when this kind of deposits are occurring, what we are getting over here is a very narrow platform, a very narrow platform is produced over here, and we are getting some deposits going on in this portion, and the rest of the portion, the deep basinal area, this is now actually not affected by any process, and there we can get some chemical precipitation other than carbonate. Some chemical precipitation can go on over here, can start over here, including some maybe some salt, maybe some evaporites. All these materials can get deposited over here during this phase. So, this is the overall scenario during the FSST and the LST phase in carbonate platforms. So, the fundamental implications of the base level fall in the context of the carbonate self is that the carbonate factory gets shut down following the subaerial exposure. So, that is the major event, that is the most significant event that occurs during this forced regression, as well as it continues during the low stand phase. As you can see over here in this condition, say for example, this is the last phase of forced regression, and from there when the base level starts rising during the LST, even during that phase, this area, if this is the level which is reached at the end of the LST, so base level started rising, but even till this time this entire self is exposed, this entire self is going through this karst process and it is experiencing shutdown of the carbonate factory. So, during the LST as well, this carbonate factory shutdown is very much conspicuous, very much important, and that is the most significant event in LST and FSST in carbonate environments. So, in response to that, the carbonate platform is subject to karstification. So, the fluvial systems, they starts advancing across the continental shelf and they try to adjust to the lower elevation of the shoreline, just like the river incision process that we have discussed earlier during FSST in siliciclastic system. So, exactly same kind of process occurs over here and the resultant product is a karstification. So, fluvial incision coupled with dissolution of carbonates, these factors together leads to the development of several karst structures which may be preserved in the rock record in the process of burial during the subsequent stages of base level rise, and when they are preserved in the rock record, they give us information about this falling stage. They give us information about this changeover, about this shutdown of the carbonate factory. So, this is a very important clue in sequence stratigraphy, particularly when we are looking into the carbonate sequence stratigraphy. The karst topography at the top of the exposed carbonate platform commonly reflects that the relief associated with the subaerial unconformity within the carbonate successions. Such unconformity surfaces, they commonly serve as the sequence boundary, particularly for the depositional sequence boundaries, and they may separate the high stand carbonate deposits which have been accumulated below this surface and the transgressive carbonate deposits which have formed during the next phase of transgression, which are lying above this surface. Because after this phase, if you look into the base level curve, we will be moving into the transgression, and during transgression water level will be rising, sea level will be rising, and there will be again start of production of carbonates into the self environment. So, across this karst surface which can act as an unconformity, as it is indicating a time gap, as it is indicating a phase of erosion, weathering. So, we can consider this as a major boundary in carbonate sequence stratigraphy. The process of karstification, however, is controlled commonly by the climatic conditions. So, it is a climate dependent process. So, definitely where the climate is not favorable for karst formation, say for example, in more arid conditions. So, in that kind of condition, we may not get a karst formation, but we can get a calcite profile. So, in that kind of condition, there may be a less topographic relief and that kind of calcite profiles may form in place of the karst topography. When the forced regressive shoreline, they commonly falls below the elevation of the shelf top, which is very common. In such conditions, considering the overall shallow depth of the high stand platform, the much steeper slope may only support the development of relatively narrow belt of carbonate deposits, and that results in a very narrow carbonate platform that I have shown you in the diagram. So, only a small amount of carbonate sediment is expected to be shed to the deep water environment, during the entire phase of falling stage and which may continue into the low stand interval. In the deep water part, since the carbonate shedding is stopped now, so in the deep water environment there is a sediment starvation, there is a lack of sediment supply, carbonate supply, and that may promote, that may lead to precipitation of other chemical deposits on the sea floor. This is another characteristic feature we can expect during the falling stage. So, with this I would like to conclude over here. So, in this particular class we have tried to understand about the different systems tracts, and we have started with the HST, high stand systems tract, and followed by that we have tried to understand what happens during the falling stage and the low stand systems tract in a carbonate depositional environment. So, when we look into the carbonate shelf, HST is the best time when we get the maximum accumulation of carbonate deposits, where the carbonate factory they tries to keep up with the rate of rise of the base level, and they maintains a balance, as well as they supply the sediments, the extra amount of sediments which are covering up the entire accommodation available in the shelf area, they are supplied into the depressional part. However, during the falling stage and the LST, the conditions are completely different. As the base level falls, base level comes down to the shelf edge or even maybe below the shelf edge, the entire shelf area gets exposed. It goes through karstification, weathering processes, and that can form a very major unconformity surface. So, during this kind of condition, the carbonate factory is shut down. Only we can get a narrow platform formed within the slope area because of this low water level, where the photic zone is maintained, where that particular depth zone is maintained, and we can get deposition of carbonates in the depressional area within a very narrow zone, forming a very narrow platform. So, what happens during the transgression, that we will discuss in our next class. So, this discussion will continue in our next class. These are some of the references that you can go through for further study. Thank you everyone.